Hello friends. So where we left previously, we left at Foster 1 and Foster 2 forms. So we will be starting from the numerical of Foster 1 and Foster 2 form. So here you have got the function which you have to design in Foster 1 and Foster 2 forms, right? So first step in synthesizing a circuit is to know whether the given circuit is LC, RC or RL circuit. So if you directly look at the impedance function, you are going to find it out that it is even to odd function. So when the function is even upon odd or odd to even, we have learned the property that the given system will be made with only L and C components. So this is our step number 1. Step number 2 is, because we know that we have been told to find out the Foster forms. Foster means partial fractions. Just keep this thing in your mind that wherever Foster term will come, you have to go for the partial fractions. But one thing that you all should keep in mind is, for carrying out the partial fractions, the degree of numerator should always be less than the degree of denominator. Can you see here? The degree of numerator is 4 while the degree of denominator is 3. So that means your this condition is not fulfilled. So if it is not fulfilled, you have to go for the one step CFE. What is one step CFE? Simple division in one step. So the divisor is going to divide it and you are going to get this as the remainder. Can you see it? So your this whole function is going to get replaced with the quotient term plus the remainder term divided by the divisor. Can you see it? Your this whole term is divided and it can be written like this, right? So let me rub this thing first now. Now you all can see that this is in our simple form, so I can just give it a name of Z1S. But what about this? This is not in the simple form. Simple form means a single term. So we can directly write 24s square plus 36 divided by s into, I'm going to write it in this form only, s upon s square plus 4. So I'm going to write down with the partial fractions. So it is written as a upon s plus bs upon s square plus 4. I think you all have gone through the partial fraction expansion, how you do it. So here it will be s square plus 4 and here it will be bs into s. So by comparing the coefficients of s square, like 24 is equal to a plus b, and comparing the coefficients constants, 36 is equals to 4a, you are given with a equals to 36 by 4, that is 9, which gives you b as 15. So I'm going to replace b and a value directly here with 9 upon s and 15s upon s square plus 4, right? I think this is clear till now. So now I am going to rub all this. So now, including the previous function, that is z1s that we wrote there, the complete this function is going to give me the value, this whole thing is going to give me the value of 4s plus 9 upon s and 15s upon s square plus 4. Now this is directly z1s, this is z2s, and this is my z3s, right? Now I told you to learn a table that I told you that we are going to require it again and again of the elements and the, so I'm going to write it here. This is your element, this is ZS, and this is YS. If it is your resistance, that is taken as R, so here it will be 1 by R. If this is your inductor, it is taken as SL here, 1 upon SL here. If the capacitor is there, impedance form 1 upon SC, and in this form it is SC. Now we all know that we are going to make this circuit using L and C. So just see here, in impedance form, your LS means what? Can you see here? It is your L1S. So you have, sorry. So this is your L1. So the value of your, I told you the circuit that we get is like this, right? So the very first value that we are getting here is of L1, that is coming out to be 4 ohms. Now come on to the second one. Z2S is equal to 9 upon S. Now if you just check it out here, this is in the form, because Z2S is there, 1 upon SC form. So can I write your this as 1 upon S upon 9? Can I write it like this? That is basically equal to 9 upon S. So basically your this thing is going to, sorry, this is not 4 ohms but 4 henries. So now this is going to give me the value of 1 upon 9 farads, right? Because 1 upon 9 is there. So next we come on to your Z3S. Now mind it, Z3 is not in the simple form, because wherever a addition sign is there, that means we have to separate it out. So I'm going to write it like this, 15S upon S square plus 4. And now I am going to take 15s in the denominator, so this becomes s square upon 15s plus 4 upon 15s. This cancels out. So now you all know that y is the reciprocal of z. So when we are talking about y3, it is the reciprocal of z3. So instead of 1 upon, I can directly write y3 as s upon 15 plus 14 upon 15s, or to make it more clear, your this 14 is going to go down and I can write it as 1 upon this. So if you just check it out, I already told you whenever admittance is in the form of addition of two things, means parallel combination. Whenever z is there in the addition combination, we go for the series combination, but whenever y comes in addition of two forms, then we go for the parallel combination. This provides me with two values. If you just check, s is in the numerator, so but this is going to be your this ys. So here s into c, that means 1 upon 15 makes it to be the farad capacitor, and 15 by 14, you all can see here 1 upon sl is going to provide me with the inductor. So to design it using all these components, I'm going to draw the circuit again with the Foster 1 form. We are going to get 4 henries, then we have got 1 upon 9 farads, and then we have got the parallel combination of inductor and the capacitor, and that is it. So the value here is 4 Henry, the value here is 1 upon 9 farads. Kindly don't forget to mention the units, 1 upon 15 farads, and the last is 15 upon 14 henries. So this is it. This makes out to be my Foster 1 form. I hope you enjoyed it. So now we are going to do the same numerical using your Foster 2 form. So shall we proceed out? Okay. So now I'm going to rub it out here. I'm not going to rub this table because I'm going to require it again. So as I already told you that for your Foster 2 form, what you require to go for is the admittance function. Admittance means you have to take the reciprocal. So when you take the reciprocal, what you are going to get is s cube plus 4s in the numerator, while 4s4 plus 40s square plus 36 as the numerator function. So we can directly go with the partial fractions. I can write it as this, and I can write it as so taking this above, I can go for your s square upon 4, so this is going to give me s cube by 4 plus s divided by s square plus 1 into s square plus 9. Now I have to write it in my partial fractions form. So it will be equal to, whenever there is 2x term missing, like we write it as x square plus 2x plus 1. So if my this term is missing like in here, so otherwise we have to write in the partial fraction format as as plus b plus cs plus d. Your this term is always going to come out as 0. So I'm only going to write it as as upon s square plus 1 and bs as s square plus 9. So you have to find the values of a and b. Now when we go for the partial fractions, I'm going to get a as 3 by 32 and b as 5 by 32. So I'm going to replace these two terms with 3 by 32 and 5 by 32. So here it is 3 by 32 and here it is your 5 by 32, right? So if you just check it out again, this is in your complex form. So I'm just indicating it as, because this is y equals to, so this is y1s and this is y2s, and I am again going to write it separately. I'm going to rub it out. So now my y1s is equal to 3 by 32s divided by s square plus 1. That can be directly written as, sending this to the denominator, 32 by 3s into s square plus 32 by 3s, right? This gets cancelled out and your y1 is equal to 1 upon z1s. That gives me the value of z1s as 32s plus 32 by 3s. If you directly look here, z1 means this is my ls, plus this can be written as 1 upon 3 by 32 s. So this term is going to give me my capacitor value, right? So this is my first branch that I have got. So I will just make the circuit here, because I already told you that it will be in this form, parallel form it will be there. So I am just going to put these values. So my this value is going to be the series combination of L1 is 32 Henries, while my C is going to be 3 by 32 farads. Now I am going to take out Y2S. Your Y2S was equal to 5 by 32s divided by s square plus 9. So the same procedure we are going to do this. We are going to take it to the denominator, and here we are going to get 1 upon 32 upon 5s into s square plus 32 by 5s into 9. So I'm going to get 32, this s and s cancels out, 32 by 5 into s plus 200, and 32 into 9 is 288 divided by 5s. Now again 1 upon, so y2s is equal to 1 upon z2s. That gives me z2s as the 32 by 5s plus 288 upon 5s. Again taking this 288 to the denominator, that gives me 32s by 5 plus 1 upon 5 by 288s. Just check it out because this is equal to z. So check it out in the z column. SL means your this value is your L2 and your this value is your C2. So this gives me this branch. This was Y1 and this was Y2. So this gives me next branch of L and C components. You can always give me the value. This is my 32 by 5 Henries. I should rub this so that it doesn't get confused. 32 by 5, and this is my 5 by 288. Ta -ta -ta. Here we have got the final answer and the final structure from Foster 2 form. So now if you just check it out, this was your Foster 2 form. That is the complete all parallels. Your single parallel branch can be a combination of two series components, and if you check out with your previous, that was your Foster 1 form, that was equal to your 4, then 1 by 9, and this one, but all in series, but both with L and C components. So it was 4 Henries, it was 1 by 9 farads, this was 1 by 15 farads, and this was 15 by 4 Henries. So just check it out. This is my Foster 1 and this is my Foster 2. This is all series and this is all parallel as already discussed. So tomorrow we are going to go with your cover form, but before that I would be very happy if you are going to give me the Foster 1 and Foster 2 forms for the circuit for the impedance function s square plus 1 into s square plus 3 divided by s into s plus 2. This is going to be my ZS. So you all have to do this as your homework, and then we can take out the doubts tomorrow in our Zoom class, right? You all have to perform the Foster 1 and Foster 2, Foster 1 and Foster 2 form for your this numerical s square plus 1 into s square plus 3 s into s plus 2. Thank you so much. Stay safe, stay inside, but keep on reading. Thank you.